Todd Humphreys here from WEI. Thank you very much for joining today. We're going to be talking about a very hot topic, which is that of SASE, Secure Access Service Edge. Based on the work we do, we see it's probably one of the hottest topics and biggest movers and shakers in the security and networking business. It is truly an evolution of how people implement security and networking. Very pleased to be here with two folks from WEI. First of all, Brian Jakes, who is our Director of Networking and Security, who's helped build this practice and has been running this practice for about 10 years. And as I mentioned, the esteemed Terry Dever. I've had the pleasure of knowing Terry for over 10 years. And for those of you in the Northeast, if you've deployed next generation firewalls or deployed SSE or SASE technology, there's a really good chance you know Terry, or that Terry helped do the deployment or did the deployment for you. So I think you're in for a treat. Terry's one of the more knowledgeable people in this space out there. So I just wanted to say a few words about WEI before we turn it over to Terry. For those of you who are not fully aware of who WEI is, we are a large and extremely well-resourced VAR systems integrator based out of Salem, New Hampshire. We service customers all over the United States and globally. We've been around for about 35 years, so it's really remarkable how many people do know us and had experience with us going back that far. I represent the cybersecurity practice here at WEI, and you're going to get some exposure to that today. But it's based on a few different pillars: network security, zero trust, and SASE, SOC modernization and automation, which is a particular strength of ours, cloud security, and asset and risk management. But the historical pedigree of this company was very broad. Again, Brian represents the networking and security practice. We have a data center and virtualization team, a cloud team. We do a ton with storage and backup technology, which plays very well with the cybersecurity work that we do here. But this is about the people. And we're very proud of the fact that we've got some of the best people. And by the way, there's Terry. In this part of the country, they're local, they're there, they're at your disposal. This is what a significant portion of our bench looks like, of those 85 engineers, and they have a ton of certifications. So WEI provides a really fertile ground for these experts to work. We encourage them to get certified, and they do it. These are the people that are available to you. From the perspective of the SASE discussion, we have some of the best SASE experts, network security experts in the region, and we're here to help and aid in the discussion, aid in project planning, and aid in deployment of the technology. So that's a little bit of background about WEI. I would recommend that if anyone has questions as we go, please use the chat. Brian and I will be monitoring the chat, and we'll try to answer your questions as we go. If they queue up, we'll set up some time afterwards to have a conversation with you to get your questions answered. So with that said, I'm going to turn this over to Terry. He is the master of ceremonies for the remainder of the day.
Thanks, Todd. Appreciate it.
Oh.
I probably should have said that you're esteemed, not me, but I digress.
Well, thanks.
So I really appreciate everybody coming to check out my presentation. The title of it is Why SASE Can Help Transform Your Network. I want to kind of dive right into it and talk about what we're going to cover. We're going to talk about some of the current challenges you have with your current networks out there, and the key considerations for SASE, which stands for Secure Access Service Edge. We're going to do a quick intro to SASE and break down that acronym and find out where the rubber meets the road and what it actually means. It's kind of a loaded term, and I want to define all that for you. We're going to then sort of pivot and talk about something called Zero Trust Network Access, or ZTNA 2.0, why that's important for SASE. Basically, any SASE product, or what I'm going to refer to as, I'm going to interchangeably refer to it as a SASE product or a SASE service, but it's basically a SASE product that you buy from some of the top companies out there, right? They should all be based on the principles of zero trust network access. And we're going to go through what that is. And based on that, you're going to know what to look for in a SASE product. Then we're going to do a deeper dive into SASE. We're going to go through a quick design and talk about how it all fits together, how users connect, how branches connect, how data centers connect, how SaaS security happens, and all that stuff. Then we're going to, again, talk about what SASE is not. That way you can sort of clear, the fog from all of these terms and kind of remove the mystery as far as what to look for in products out there. We're going to talk about zero-day malware prevention, why that's important, why that should be tied into any SASE product, and then we're going to wrap it up and go with any questions. Um, that said, we're gonna dive right into it. We're going to talk about some key considerations for SASE. So the first thing we're going to do is we're going to look into what's happening currently and look at a traditional network. With a traditional network, you typically have branches and mobile users scattered everywhere, and they're usually doing something called backhauling back to a data center or back to a headquarters, meaning that their connections from the branch, whether that's in China, the UK, India, Pakistan, Africa, or other places in the US or South America or Europe or wherever they are, they typically are going to backhaul back to a data center to send data. And when they do, they're going to backhaul, example from China, the worst latency there is they're going to encounter latency. And what I've seen is if there is an MPLS WAN or site-to-site VPNs or whatever it is, whatever your method is of connecting back to a data center, you're going to incur anywhere from 300 to somewhere around 450 milliseconds from what I've seen going back to that data center to transmit data back to that headquarters. And let's say hypothetically you're at a branch and it has a legacy router and it's in China and you're going back all the way to the data center and then back out to the internet, you're eventually going to find out that you have latency going back out to the internet. And when you go to Google and Yahoo, there's going to be no localization, meaning that you're going to expect websites to be in Chinese. Lo and behold, you're getting English and you're getting local information and local news from Boston or New York, right? That's not, kosher for the user, right? So then when they need to go over to a branch, they're going to come all the way back here and they're going to route back to the branch. So eventually you're going to say to yourself, okay, it's less latency to get out to the internet, to go to Yahoo or Google, but also go to my SaaS applications like OneDrive and Box and Slack and Salesforce locally at the internet choke point right here, right? That's gonna decrease latency, but it's also gonna significantly decrease security, right? And if you routed all the way back to the data center to go to this branch, you're going to go about 300 to 450 milliseconds down to the data center, and then to about 100 to 150 milliseconds back over to the UK or back over to India. Lots of latency going on there, right? Lots of backhauling. That's called backhauling. And I'm going to talk about the good news and the bad news with all of this, right? With the mobile users, those could be anywhere today. We all know since the pandemic, since everybody got sent home, we all work from home, and then we sort of like overloaded our client VPN connections and things like that going back to our companies. So a lot of people looked to a SASE service to mitigate all that, to allow them to connect from anywhere. So a lot of people did, and these users can be anywhere, whether it's the US, China, India, Europe, wherever they are. And when they do that, it's again, they're going to encounter latency coming back to the data center, going through the security stack down here, which could be multiple point products like firewalls and intrusion prevention devices and URL filtering and this Congo line of security products, and then back out to the internet. They usually tell the users, okay, go to the internet locally to go to Google, Yahoo, ESPN, or whatever, and to use your SaaS applications, right? The problem with that is there's very little security right here, and you just sacrificed good latency for bad security. Um, Another piece here is this network has grown organically, where this engineer who implemented the left side of the diagram implemented site-to-site MPLS to everywhere, but they did site-to-site VPN to certain locations, but not others. Another engineer came in and said, okay, we're going to implement an SD-WAN between two or more branches. And yes, you have that full mesh connectivity, but now you just, again, sacrifice security. You're going directly from branch to branch instead of going through this secure stack, right? So all the traffic and security controls might flow through and might be anchored through an on-prem security stack, or worse, security might be enforced at the perimeter of each branch, forcing you to configure each branch device one by one with no consistency of security policies. And then you figure how many perimeters are there? Every user at home, every branch, every application where they're placing their data, the headquarters, the data center, all of these are perimeters. So wherever you're connecting a data connection, whenever you're connecting a data connection to any resource, you're exposing an attack surface and you're exposing your data. You might be leaking data out to attackers and competitors. The more attack surfaces you have, the greater risk that someone will find the weakest link in your organization, exploit that, and steal your data, which makes you competitive as a business. And because of many point products that I mentioned, there's unruly routing, there's unruly remote access, there's no differentiation between internal users and external contractors. There's that Conga line of security products all doing different things, and there's a device for everything, and those devices don't correlate threat intel, like indicators of compromise and things like that, and log entries with other security products in the same security stack, like if you have multiple products down here at your data centers. So this is also a big cost, maintaining all that with very little security outcomes. And you have fragmented solutions impacting networking, routing, and like I said, security outcomes. There's no consistent security policy. There's very little visibility into what the users are doing. If they're having latency, jitter, or delay, you have to sort of chase your tail and figure that out. And there's product sprawl and maybe even agent sprawl. Maybe you have an agent for antivirus, an agent for VPN, and they should all be sort of one thing. There's disjointed security and networking. Users are everywhere off-prem, applications are off-prem, and you're backhauling data back to a data center. All of that is latency. There's little mobile user security. It's sort of a bad confluence of circumstances, coupled with the fact that there's little to no security for SaaS applications. And if you juxtapose that with today's reality, right? Work is more of an activity, not a place anymore where you go. A lot of people are working from home. They might be working from home in a hybrid mode, 2 to 3 days a week. The applications are everywhere. Users are everywhere. Branches, users, and applications are now the perimeter of the network. The perimeter is no longer a place. It's a capability. And the perimeter is everywhere when threats to businesses are at an all-time high with terrorist organizations and state-sponsored attacks and all that stuff. The goal is to decrease the attack surface and implement zero trust despite a sprawling mobile and borderless perimeter while protecting application traffic and having the best-in-class security, but also an exceptional user experience. So that's really what the goal would be. And then I want to talk about some key considerations that I hear a lot of my customers talk about, and I want to kind of talk about their common pain points that sort of keep them up at night. Some examples. Maybe some of you folks out there who are managing networks, maybe you've heard of Zero Trust Network Access or ZTNA, and you don't know what it is, or if your environment is capable of it, maybe you need to define what ZTNA means to your business. Is your business keeping pace? Is it behind pace or outpacing attackers and current threats out there in all phases of security? Or is your network high maintenance, but also lacking security, high maintenance and high cost? What is your current security strategy? And do you have a consistent security posture everywhere? Where is the weakest link? Today, more than ever, there's a need to transform that network and security with one unified product, with one GUI instead of multiple, for the headquarters, the data center, the branches, the mobile users, and also SaaS applications. SaaS meaning software as a service, your Salesforce, your Workday, your Microsoft applications, your internal applications as well. That's what I'm referring to when I talk about SaaS applications. People also, I hear people complain about poor end user experience where client VPN is needed for some applications, but not others. Like myself at WEI, I don't really VPN in back to WEI unless I need to stage something for a customer. Other than that, I'm using Workday, Salesforce, Microsoft Teams, O365, and all these things. So it could be that my SaaS app performance is slow and there might not be visibility into where data is going. And then that's for internal users. And then you talk about external users like contractors. Should you allow external users and contractors access to all of your network, all of your resources, right? Um, on desktops, do you have multiple agents for multiple functions? And do you know where the application latency is without full visibility into what that user is doing and how they're going to that application without doing things like packet traces and using tools like JPerf and iPerf? It can also be expensive from an operating expense or OpEx perspective. You have you have edge devices at all these branches and headquarters. You need to license them. There's software and hardware upkeep. There's power, there's cooling, there's failover, there's managing multiple products controlled by multiple admins with multiple GUIs that affect things like routing, networking, all with different security policies. None of it's consistent. None of the devices correlate threat intel with each other. And all of that adds up to complexity and latency and all these things. And then you add in the expensive WAN links, and now all of a sudden your budget is kind of overblown. Coupled with that, you have an increased attack surface, and you have to ask yourself, do remote internal users, do external contractors and branches have too much access to every resource, especially resources they don't need access to? If so, it's definitely time to transform your network and transform your security. Do you have perimeter sprawl or what I call back sprawl? Multiple point products, like I mentioned, at a data center with some doing firewalling, IPS, and all these things at multiple sites, and you're managing next-gen firewalls and routers at multiple sites that don't correlate threat intel with each other. All of that adds up to perimeter sprawl or an exponentially expanding perimeter and expanding attack surface for you to maintain. Multiple products increases the possibility of human error, misconfiguration, potentially leading to routing and security issues. How will your security strategy deliver when people, applications, and data scatter everywhere? They go home, they might be working from anywhere, and the attack surface is expanding while hackers are innovating. Why not have one security as a service with one graphical user interface or GUI with one consistent security policy everywhere while preventing known and unknown zero-day threats at each perimeter? So kind of what we keep coming around to is a need for global scalability and flexibility, a product that can deliver one security policy, one security strategy with next-gen level security that's local to every single user, every single branch, everywhere. It scales up and it scales down with the volume of traffic, and it allows for daily projected traffic growth. Traditional network and security designs, like the one I mentioned, are complex, costly, unruly, disjointed. We need transformation in those networks. Wouldn't it be better to optimize your environment for network performance and security without sacrificing end user experience and do that globally and scalably? That's what we're talking about. That's why people gravitate towards SASE. Any questions so far? Am I missing anybody? Okay. So I'll go into an introduction to SASE. So this just kind of exposes the technology, and I'm going to expose the sort of the business impact of why you would want it. So again, SASE stands for Secure Access Service Edge, and I'm going to break down that acronym because it's kind of a loaded term. If you look at this diagram from the bottom up, I'm going to look at the this purple part right here. The secure access layer means that mobile users in branches and data centers in headquarters are connecting to the SASE service. And they might do that various different ways. You have mobile users that connect via client VPN or explicit proxy or clientless VPN or software-defined perimeter. However they connect, they do it securely. You have branches that might connect with any IPsec capable device, so that's a good thing. You can, if you needed to connect to a SASE service, you don't really have to get rid of your legacy routers and firewalls. You could take advantage of the security as a service by connecting directly to it. And you can do that in the interim until you flip it over to SD-WAN, for example. And I'll talk about that in a few minutes. Um, it's that shared model as well. So the shared model means that you as a company, you as an administrator, do not need to worry about anything else but your security policies, your security policy rules, your SSL and TLS decryption, your SaaS security. You only worry about that. The provider of that SASE service, whether it's Palo Alto Networks or Cato Networks or Zscaler, HPE or Aruba, Fortinet, Netscope, whoever it is, they worry about the service infrastructure and the scaling and the fact that it's globally available and it scales up and scales down with the volume of traffic, and that it's geo-redundant, and that there's a local point of presence to onboard your mobile users and your branches to the SASE service for everybody, right? So it's globally available, your network, your private IP addresses, your public IP addresses, your users reading from that user database that you have internally, right? Your branches globally, right? Your environment, and it does not interact or bump into or, ships passing in the night from any other customer that has a SASE service with that vendor. Now I'm going to go up to the yellow part here, which is where I talk about the service edge layer, the SE in SASE. Some people also call that the secure service edge, right? So it could be called SSE or it could be called SE or service edge. And what you're looking at there is you're looking at your next gen firewall as a service, your secure web gateway to allow sanctioned applications, block unsanctioned applications, allow tolerated applications, doing data loss prevention, doing SaaS security, zero-day malware prevention, reducing the attack surface, making sure that the users are authenticated and they're two-factor authenticated. It's making sure that it's scalable and elastic, scaling up and scaling down. And it's that shared model doing SSL and TLS decryption, zero-day malware prevention, and all this stuff, while you're also doing branch connectivity, user connectivity, right? So they're connecting at the secure access layer, and then they're taking advantage of the services, the secure services at the service edge layer. When they do that, all of that traffic from the mobile users, the branches, the data centers, it's all traversing the SASE service. So it's as if you took your firewalls that are at your branches and on-prem, and you lifted it up, put it into a global environment. Now everybody's connecting to it as if every branch is like a Starbucks, right? So it's scalable and secure. One thing I want to talk about with SD-WAN, SD-WAN is a key component of SASE. SASE has the secure service edge as well as SD-WAN. They have to have both in order to be a SASE product. For those who aren't familiar with software-defined wide area networking, or SD-WAN, the goal with SD-WAN is not to simply route traffic based on layer 3 and layer 4 based packet-based policies, which it also will do, but you want an application-defined SD-WAN steering traffic over multiple paths or different paths defined by you, the admin. Give applications a guaranteed quality of service, especially voice and video applications. Have constant insight into how the applications are performing, how the applications behave on each path. Do they need to take another path? This means link and application health details, performance insights as far as jitter, delay, and packet loss over that link, media analytics, link quality. Is that link bouncing up and down? Is it tapped out as far as bandwidth? You have application flow details, routing details, With SD-WAN, you have symmetric-based application flows over multiple links. You have per application thresholds to switch applications over to other links for failover to protect against one application, like, for example, a user watching Netflix, starving out voice and video and Microsoft Teams traffic and things like that, protecting against link down, applications starving out other links, link brownouts, with doing all this with very little or no manual intervention needed by the admin. The configuration is centrally orchestrated so that you can plug in an SD-WAN device or an HA, high availability pair of SD-WAN devices at a branch or at a data center. They get DHCP, they connect to the internet, and now that template that you configured can be pushed right down to that device. So you have centrally orchestrated, software-defined networking, zero-touch provisioning, but it's also done from the same GUI as your SASE service. So it's this one unified product with secure service edge and thin branches everywhere, right? One thing I want to note here, again, I'm throwing a lot at you. I apologize. It's kind of a quick presentation, but with the secure service edge, you're not actually shipping a product to a customer. It's all a virtual product that you purchase and then onboard into. The only physical product that you would have in a SASE service would be the on-prem SD-WAN devices. And I'll get into what they can do at the branch a little bit later. The next thing I'm going to talk about is I'm going to talk about this exact diagram, but I'm going to look at it from a different perspective. I kind of feel that, like, when I'm talking to people, if they see a diagram from two different perspectives, maybe it'll resonate. So I just wanted to do that for everybody. Biggest thing I want to get across here is that the typical use cases for secure access service edge or SASE are VPN replacement, replacing your current mobile user VPN on-prem with the SASE service, right? Can still use the same user database that you use today. You can still use the same two-factor, multi-factor authentication, but you're simply connecting them to a different portal. That's really all you're doing. When I talk about VPN replacement, I'm also talking about branch VPN replacement with SD-WAN and IPsec VPN, having those branch on-prem devices connect over to the SASE service at their local point of presence, so that SASE service is always local to the branch and the mobile user, no matter where the branch or mobile user is. So very little latency getting from that branch to another branch or from that branch out to the internet, and same for mobile users, right? Secure web gateway that I talked about earlier, SaaS security that I talked about earlier. But one thing I want to talk about there is in addition to what I talked about with secure web gateway, where I'm sanctioning, unsanctioning, and tolerating applications. With SaaS security, I can have a product called Next-Gen CASB, or Cloud Access Security Broker. What that means is that I'm onboarding an application, well-known application like Salesforce or Dropbox or OneDrive or O365 or something like that, or Zoom, into my application, right? Into my SASE service. And that SASE service via API is looking into that and making sure that I'm not uploading or downloading files from a bad source, and that I don't have malware that can be contained in files that users are now downloading, and that I'm not oversharing files that would spread my intellectual property to competitors, right? And again, I talked about that network transformation with thin branch with SD-WAN. That's also a facet of SASE, right? One thing I want to touch on is SSL decryption. It's typically been a challenge for a lot of companies to implement. Why? Because they usually have an on-prem firewall that they need to make sure that it scales with that volume of SSL traffic that just keeps growing. With SASE, you just purchased a service. That's all you have, right? The manufacturer is worrying about whether it's scalable or not. You turn on SSL decryption, it's globally everywhere to wherever your mobile users connect, wherever your branches connect, wherever your data centers connect. And you don't have to worry about whether it's scalable because you've done it and configured it via this scalable global service. This section has 2 slides. I always want to keep people aware of how many slides they have left so that they're not like not wondering what's going on and that I'm not like droning on endlessly. This section has 2 slides. And when I talk about zero trust network access, what I want to do is I want to define it. Then I want to show the business outcomes of what ZTNA can do for you. So when people talk about zero trust network access, it's based on 5 pillars, right? And you see them left to right. I'm going to start with least privilege access. I'm going to define each one of these, and I'm going to summarize them so that you have a good feel of it when you walk away from this presentation. Why do we want to talk about ZTNA? The traditional networks and VPNs that I talked about earlier have trusted users and the devices they're on, granting them full network access typically to on-prem resources. And those could be internal users, they could be contractors. I know I've been a contractor for about 20 years of my career, and I do know that my customers typically let me VPN in, they give me an RDP desktop, so to speak, a virtual desktop to go to, and then I can pretty much go anywhere in their network. I never violate that trust, but like you could unknowingly violate that trust if you have malware on your computer or whatever it is. This is allow and ignore. That's something you want to move away from. Your company data can be attacked, your data can leak out, and there could be exploit attempts. Full access, regardless of risk, is bad. Zero trust is a security approach. It's an architecture. It's not a product, but any SASE product should be based on the 5 pillars of ZTNA. And what ZTNA does is that it verifies each user in each device, granting access to specific resources without assuming that every internal user or every contractor should be granted full trust, right? You're restricting which users can access which applications and resources. You take back access control over your environment and your data. That's really what it's about. So ZTNA continuously monitors user activity, and while they're connected, it re-verifies access, reauthorizes them, ensures that there's no risky or unauthorized actions occurring while the user's connected. There's continuous traffic evaluation while the user's connected, while the branch is connected, preventing compromise, data loss, and with consistent security policy decisions based on user identity, application flow, data flow, application access, where the connection is going, globally and fully in line with all of your data because everybody is connected to the SASE service. Nothing should ever be implicitly allowed. Never trust, always verify. That's the biggest piece that I can convey to you. Never trust, always verify. So I'm going to quickly define the 5 pillars of ZTNA 2.0. I'm going to start on the left with least privilege access. That's the #1 cornerstone, the most important cornerstone of ZTNA. It's literally identity-based computing. Who, by username, by user group, the devices that they're connecting from, are those devices trusted? Strict authentication for both the users and devices. Where is the connection sourced from? Is the connection sourced from North Korea or someplace like that, right? When are they connecting? What is the user trying to access? Are they trying to access an external application, a good domain, a malicious domain that we just found out was malicious yesterday or 2 hours ago? Is there malware in the flow? Is this a known bad application that should be denied via my secure web gateway? Is it an internal application that only certain users should have access to? Like I'm a software developer, for example, and I'm trying to access an accounting application. Should I have access to that? The answer is probably no, right? Nor should an accountant have access to the source code that makes the software company tick, right? Is it a sanctioned, unsanctioned, or tolerated application? Via which path is the flow traversing? And what if you're a contractor? Should we allow and ignore your connection? Further, what if it's a camera or a printer or like a device that's in a fish tank or something like that that can be compromised and is trying to get data out of your network? Implement least privilege access based on those factors. Then continuous trust verification. Once connected and access from a user and device is granted, trust is continuously assessed throughout the life of that connection based on the user, the device behavior, the application behavior, user and device profile checks or posture checks to continually check any changes in endpoint behavior, enforce authorization, block inappropriate traffic. Maybe that user device has malware and the end user is unaware of that. Then you can quarantine the endpoint, get it remediated, and quarantine the user if needed, right? Do continuous security inspection. This is preventing inline threats such as known malware and unknown malware, where attackers can steal your data in ransomware and things like that via inline next-gen security, while also doing SSL and TLS, decryption inspection, right, of all traffic traversing the SASE service, all before the malware is downloaded, shared, executed, and before it spreads laterally to the rest of your organization and it's doing this via ongoing inspection of traffic connections from misbehavior, exploits, vulnerabilities, and stopping code executions all in real time. Going forward to the two on the right here, protecting all of your data, your intellectual property, and it's quote unquote the secret sauce that differentiates your company and what you do as a company versus a competitor is key to your competitive advantage. Therefore, what you need is data-aware infrastructure preventing data loss by ensuring that sensitive data is not leaked to unauthorized destinations via data theft or accidental oversharing using like OneDrive or Box or Dropbox or whatever file sharing you have, while using common tools like SaaS applications that do collaboration and file sharing services. Take back control of your data. Then protecting all applications. This is allowing users to certain applications on a connection by connection basis, access control, preventing risky file shares, malware scanning of data uploads, downloads, or data at rest, safeguarding all applications. All of this happens within that SASE service that's global and it's at the closest geographic region, closest to the user on a per session basis. That's what we're talking about there. The next thing I want to talk about is some business outcomes of ZTNA. So I wanted to, in the top bullet, I wanted to remind everyone what the 5 pillars of ZTNA is. So, you're not like me, you memorize the stuff, right? But I want to have that there to show everybody some things about the 5 pillars, that mantra of never trust, always verify, that it's user and application centric. You have inline control and malware inspection and all that stuff. Why should you care about ZTNA and why is it important? Next-gen networks and perimeter sprawl of users and applications and branches and all the stuff everywhere. It's like herding cats, right? That sprawl forces the need for next-gen security today via a SASE solution that delivers security based on the 5 pillars of ZTNA, and it does it scalably and globally, right? If I had to summarize ZTNA into 2 specific bullets, I would say that ZTNA is a security approach and architecture verifying every single user group, every single device that they're connecting from, whether they're at a branch or they're a mobile user, granting access per application without assuming that they're trusted, without assuming that that connection is trusted, while mitigating exploits, vulnerabilities, and malware inline, globally, continuously monitoring user activity and ensuring that no unauthorized actions happen even after access to the network is granted. So if you consider the everyday outcomes, you're modernizing your secure application delivery and security to the end user and branch. You're simplifying the user and application experience from literally anywhere globally. You're doing that securely to deliver data securely when the user, application, and branch are everywhere. You're increasing visibility. I'm going to talk about visibility in the next part of this. That's called something called digital experience management, which is a typical feature of most SASE services. Keep that in mind, and I'll go through that in the next slide, while also curtailing and lessening your IT expense and complexity, right? You're managing everything from one place. You have one single security product for all of your needs, right? Um, Basically, all roads lead to security. SASE is that control plane redesigned using ZTNA as an architecture or framework. Instead of data being behind a data center and secured behind a castle and moat infrastructure, you need a secure controller that protects your data no matter where you are. Really, the bottom line is in a product you're evaluating, a SASE product that you're evaluating, you have to make sure that the product supports ZTNA for all connections, and improving that concept out. WEI can help you determine this. So now I'll take a deeper dive into SASE. Todd, did I miss any questions so far?
There were a couple, Terry, but we're dealing with them on the. I know Sean and Brian are chiming in on some of these.
Okay, cool. Let me
Yep.
know if I need to chime in. I'm fully willing to discuss.
Cool. I think you're rolling. I think we got it.
All right, cool. So what I want to talk about is the SASE architecture at this point. Again, I want to remind everyone in the early days of networking and next gen security with next gen firewalls, everyone had a firewall. They had challenges sizing that firewall and compute resources, especially when they want to do SSL and TLS decryption. They had another device handling packet inspection. They had another device handling mobile user connections. Sometimes, other times, they had another device handling IPS. It was a product sprawl and there was a device for everything. It was kind of like, and I get a guy for that type of mentality. Juxtapose that with SASE. SASE is a convergence of networking and security as one single scalable global security as a service solution. One perimeter, regardless of where the connection is coming from or going to, with zero trust inline for securing traffic and access by identity, branches and infrastructure, and applications, while providing scalable inline content inspection everywhere globally with per user, per application visibility. What does all that mean? So I'm going to break that down at like where the rubber meets the road right here. Without being partial to any SASE product vendor whatsoever, this is just completely agnostic. If I start from the middle of this, right, this part here, no matter which SASE product you purchase or evaluate, they all sort of have some commonalities. And this is not just according to me, this is according to Gartner and some of the SANS and all the industry experts out there. There's typically a point of presence that's local to you. That point of presence could be a physical one that the manufacturer deploys, right? They might deploy it in the same data center that AWS and GCP and Azure live in. Like, for example, if you're in the Boston area, there's a lot of these SASE points of presence in the Markley data center and in the Lowell Markley data center and a couple in Connecticut, right? And in Arlington, Virginia and other places, right? Everywhere with his cloud services, right? So that's the most logical place where people deploy these, right? Or some manufacturers have virtual points of presence that are deployed within Azure, GCP, and AWS, right? Whatever the flavor is, that SASE service should be local to you and it should be scalable. So when I have a user connecting, I have this user connecting to a local point of presence or POP, right? My data center is also connected to its geographically local point of presence or POP, right? So, and my branches are as well. So if this branch is in China and this data center is in Boston and this user happens to be in Germany, they're all connected to your SASE tenant for your company or your higher ed organization or whatever company you're coming from, right? So that's really the first thing, right? That they're all sort of interconnected. And any data that's coming from the branch going to another branch or from branch to data center or from mobile user to data center or branch or from any of these entities out to the internet, it's all forced through this SASE service, right? So the user might be using a client VPN and they're connecting locally. So there's really no reason for them to do split tunneling and go to the internet locally for some things and go to the SASE service for other things. it's as local to them as their local ISP. So why not connect via client VPN or explicit proxy or clientless VPN? There's really no harm, and there's really not going to be any latency if you do that, no matter where the user is, right? Same with the branch. There's really no reason for the branch to connect directly to another branch or connect to the internet locally. They should go through the SASE service because it's as close to them as their local ISP. So that's what I mean by globally available and locally close, network close to every user and branch, right? Um, when you're configuring everything, when you're configuring security policies and SSL and TLS decryption for mobile users and branches and data centers, you configure it through one GUI that's typically a web page. It's cloud hosted, right? You go to a web page no matter where you are, you configure everything. And then when you save the config and push it out to the SASE service, it's pushed out to all of these edges, right? So it's pushed out. So that config lives on every POP, right? So therefore, I can enforce security at every choke point where everybody connects, right? Same with SaaS security. With SaaS security, I'm onboarding that SaaS application, whether it's Box or Salesforce or Dropbox or OneDrive, into the SASE service. I put in my admin credentials for that SaaS application. I'm onboarding that SaaS application into my service. Therefore, I have visibility into which users are uploading, downloading files, which data is at rest, where is it shared to, does that data have malware, and so many other things that I can look at, right? I can also have visibility into what other non-public SaaS applications or non-well-known SaaS applications most of my users are using just by looking at the GUI and saying, okay, I have 2,000 other applications. Should I really sanction the use of Netflix or Hulu or Paramount or something? Not really business related, but I could sanction these other applications that I see people using. So I'm sanctioning them. I might unsanction or block other applications that are going through my secure web gateway, and I might tolerate other applications. When I'm doing all that, I can also do data loss prevention or DLP, right? And I can make sure that no data is being, none of my intellectual property is leaked out to competitors or out to attackers. That's kind of the first thing. Um, Second thing is, if I shift back to mobile users, the mobile user, let's say, again, this user might be a software developer, this user might be an accountant, right? This mobile user has access to the source code of my company, right? That's my product that I sell. The accountant, the CEO, whoever else, the support person, the admin, the receptionist, whoever else, doesn't need access to that, right? That's how accidents can happen. Not only that, but this developer doesn't need access to all the applications that the CEO has access to, and the accountants and the financiers have access to. That is least privilege access, right? That is curtailing that access from user to application and doing that globally. Um, Also want to talk about how these branches connect. These might be legacy branches, like for example, this one that I have my mouse over right here, that might be a legacy branch that has legacy router, a port-based firewall, like an old firewall, or like a next-gen firewall that they're not quite sure if they want to keep up with the licensing or maintain that. If it's IPsec capable, it can connect to a SASE service. Same with a cloud data center, right? SD-WAN. SD-WAN devices, this is a bit of a big topic, but like these devices could be two branches or more, right? And I'm connecting those directly to my SASE service. A couple of things there is that the SD-WAN device should be compatible with my SASE service, meaning that I should be able to administer the security policies as well as SD-WAN using one unified GUI, right? If I have to go to two GUIs, it technically is not SASE, right? According to Gartner, not according to me. Second thing is when I'm going from branch to branch, I don't want to force that traffic to go directly from branch to branch because that's how exploits can be proliferated, right? I want to send that traffic through my security service up here and then down. You'd think that would be latency in doing that. It's actually very little latency. So the benefits of SASE are network transformation, WAN and branch transformation, mobile user transformation, your environment globally and local everywhere, no backhauling of data, that scalability of traffic scaling up as traffic patterns increase and scaling down if they decrease. And it also answers the question of what if your company goes through a merger and acquisition? Now you have to scale up this network quickly, and you're sort of freaking out thinking yet they have to throw money and infrastructure at the problem, but you don't have to deploy really any new hardware or services. You can simply onboard those sites and those mobile users to your SASE service, and you're done, right? You just have to make sure that there's a consistent security policy. Next gen security as a service via one management console. So no matter how the user accesses the data and no matter where the user is, they're traversing the same security stack right here and getting the same security and user experience everywhere with very little latency. This is the ease of security without compromise. The last thing I want to talk about on this slide is visibility, right? I talked about application visibility, but I want to talk about something called digital experience management. Right now, you could be sort of scratching your head as far as, okay, if this user has latency getting to an application out on the internet, how do I troubleshoot that? I have to do packet captures and I have to use multiple products that are probably freely downloadable on the internet. With SASE, you have something called digital experience management. So I can look at how is that user's PC performing? Does it have high CPU, high memory? How is their connection to their wireless access point at home? Is it a good connection? Is it on the outer edge of that wireless signal, right? How is their local internet? Is it slow? Am I clipping packets at the local internet? Is the internet service up or down? Does it keep going up and down? That's something you can see with digital experience management. Then once they connect to the SASE service, how is my application performance from this point of presence here going out to the application? Okay, it measures that. Then it measures the performance from that application all the way through the SASE service back to that user, and it gives you the real-time data as far as where the latency is, right? And where the packets are getting lost and where the jitter and delay is. This way you can see that, like, okay, this user might have latency going to Zoom, but they don't have any latency going to OneDrive, for example. That is a key thing to figure out, that you don't have to now do packet captures and all these things to figure out. You can look at it in real time. You can also look at it 30 days ago, 60 days ago, 90 days ago, find out the historical data. Maybe these two users are part of the US Northwest region, and every ISP in the US Northwest region went down or keeps going up and down for some reason. You don't know, but that's something you can figure out very easily that way. So that's the power of digital experience management. That's your visibility. I want to show you, again, I want to show you the same diagram, just a slightly different way, right? So here I have branches, remote users, and mobile devices connecting to the secure access layer of SASE, connecting securely, right? They're taking advantage of the service edge. So lots of admins, when they connect branches, remote users, and mobile devices to a SASE service, they figure they're done, but you want to make sure that when they're connected, the entire reason you're connecting them is so that they can take advantage of the service edge, that firewall as a service, that IPS, that secure URL filtering and DNS security, that file sandboxing to turn unknown malware into known malware, and also get visibility going out to SaaS applications and stuff like that. So SASE really means consistent networking, consistent security policy enforcement for secure access to branches, internet, and business applications hosted anywhere. How does it do this? The SASE service inspects all traffic to identify all applications, all threats, and content. It provides visibility into the use of SaaS applications and the ability to control which SaaS applications are available to your users. SASE is available globally. It's your enterprise, your network globally. Why is all this important? All of this is natively integrated and deployed across all locations with no change to infrastructure. And next-gen prevention techniques are easily implemented, right? So if I come back up to this slide here, when I configure a security policy with malware prevention, it's pushed out to all of these points of presence automatically, wherever the user is, wherever the branch is, right? So it's globally available, it's scalable, it's in line with every packet from every branch and every user via a single security policy, one GUI, all traffic, networking, and threat prevention. This means that it's performing full stack inspection no matter where the user or branch is. So now you've just gotten your arm around all of those issues that you're worried about today. The next slide, if I move on, I just want to talk about some key considerations for mobile users, branches, SaaS applications, SD-WAN, and visibility, right? A lot of this stuff is stuff that we'll really dive deep into when we do like a SASE workshop with you, the customer. So everybody who is here should try to contact their sales rep and sign up to get to have like a SASE workshop with WEI. I think it's going to be really valuable for everybody here. But some of the things you want to consider are the number of remote users, where they are, what they need access to, and where. The mobile users can all connect from anywhere to a local point of presence or POP, even when geographically dispersed. SASE is always in line and with all traffic. There's no bypassing it. It eliminates backhauling of connections to, say, like a faraway data center. It solves for securing the mobile user when they're outside the four walls of their office. It can support many users, many branches while providing SSL decryption and TLS inspection at scale with virtually no performance hit. I've never seen a performance hit with that. A SASE service scales up and scales down based on traffic needs, and that's why you don't see a performance hit there. You have to take into consideration your projected growth of mobile users. You might have 2,000 users at your office, but how many are actually mobile? How many are considered mobile users? How many mobile users will there be when branches close down? Can you actually close branches down? Maybe you have those branches because the users go there and you know that they're secure, their data is secure, but can you just close the branch down, get rid of that cost that branch incurs every month, and make all those users mobile users and just have them connected to the SASE service? Yes, you can do that. There's also mobile user authentication and device posturing, where you need strict, secure authentication and two-factor authentication, obviously. But you also have identity-based access levels to applications. But even within that, how do you know that the endpoint is secure and compliant and is virus-free and doesn't have malware? That's where device posture checking comes in. That's where that continuous trust verification and continuous security inspection enters the picture, right? With branches, you have to project out the branch growth. How many branch sites at the company today and in the future? Do you want to keep existing branches, or do you want to sunset the branches due to rising costs like leases, owning that real estate, owning, operating, and upgrading security appliances and routers and switches and things like that? But when you do that, remember that branch office downsizing equals an increase of mobile users. And that's a good thing as far as SASE goes, because that number of mobile users can simply increase and you don't have to worry about it because that service scales up and scales down with your needs, right? The legacy edge that I talked about, you have a legacy router or a legacy firewall at the edge and it connects to the SASE service. Not a problem. As long as it's IPsec capable, branch sites can connect to SASE services via any IPsec capable device at the local POP location local to them. The consideration becomes most legacy IPsec capable devices do not support SD-WAN. So you can connect them for the time being and then one by one flip all of those branch sites over to SD-WAN so that they can use multiple links to send this application over this link, this application over another link, and things like that. It's also a very quick deployment as well. SD-WAN and branch microsegmentation. With SD-WAN, you can combine the usage of expensive WAN links, but also you can do east-west security going from one branch to another. That's what I mean by east-west security, as well as internal network segmentation, because those SD-WAN devices at the branch are typically, at the very least, zone-based firewalls, or sometimes they're next-gen firewalls as well. So you can segment each network based on putting them into different zones. And it's all done via a quick deployment. Like I mentioned, it's zero-touch provisioning. Secure public SaaS applications and private SaaS applications. What are the SaaS applications in use today that you know that you may or may not know about? Well, guess what? You have visibility into that with the SASE service. Are all of these sanctioned, or should some of them be unsanctioned? Should they be tolerated? Can those applications leak intellectual property to the wrong people? Does that application contain malware? Is that data shared with unauthorized users? You have full visibility into that using a SASE service. And you can do that all via one tool, one graphical user interface to manage all of it, to have one consistent security policy, visibility into network traffic, visibility into what each user is doing, what applications they're going to, see the application performance, see the branch traffic and branch performance, see if people have latency and intermittent problems. You can look at all of this within that one unify GUI. I'm going to quickly shift a little bit, if that's okay, and I'm going to talk about what SASE is not. SASE, according to Gartner, the way they define it is it's a secure service edge with a compatible SD-WAN service. Compatible meaning that I can manage both of these entities via one graphical user interface, one controller. Go to a website, it's a public website, you're anywhere, you can go there and you can manage your security policies and your SD-WAN from one GUI, and they easily interoperate with each other. But what some people are saying is, hey, we have SD-WAN, that's SASE, or we have a secure service edge, that's SASE. Keep in mind that unless they have both and they're interoperable, if they're not interoperable, it's not SASE. If they have just SD-WAN, just SSE, it's not SASE. If they don't have zero-day malware prevention, it's something that they need. It's something that you, the customer, should gravitate toward, right? It's something you should demand. You should demand SaaS security, and you should demand visibility into what the users and applications are doing. You also have to be aware of telco bundles, where the telcos will figure out that you're trying to get off their expensive WAN links, like their MPLS links and things like that, and they'll offer you a firewall in that MPLS service. That typically is not SASE, even though they might license out or OEM a secure service edge. So just be careful with that. It's something that you want to have the reins over, you want to have the control of. Let's talk about what Gartner thinks about the industry. So without mentioning any company names, and again, I'm being vendor agnostic here, right? You want to look in the top right as far as who the leaders are as far as SASE goes. What this means is that any of these vendors in this Magic Quadrant, they have a secure service edge and they have SD-WAN, right? These are the leaders in the top right. This is not to discount or disparage any of these other manufacturers. They're all great companies. They all have great people working there. Many of those people are my friends and things like that. I don't want to talk ill of anybody, but I'm just letting everybody know that these are the leaders in the top right. These are the ones that you may want to do a proof of concept with first, because that's what the industry thinks of them. One thing you'll notice here is that there is one prominent company that's not listed there, Zscaler. Zscaler is a great company. They have a great product, right? They're not listed as a SASE in the SASE market because Gartner considers them to be more of a secure service edge company because at the time of this writing, they didn't have an SD-WAN product. That's the only reason they're not there, right? They acquired a company, they've integrated into their product. They now have an SD-WAN product. I just want to make people aware of why Zscaler isn't there. Again, great company, great people working there, but this is just simply according to Gartner. Next thing I want to talk about is what Gartner thinks about the secure service edge market. You'll notice some of the typical players here, right? Yes, some of these companies have SASE services. They have SSE and SD-WAN. This is just talking about the secure service edge part of their product, right? And that's how Gartner sort of categorizes them. All right. So the last thing I want to talk about before we wrap it up, I want to talk about zero-day malware prevention. And this is a very busy slide that I ripped off of LinkedIn. I think it's poignant. I think it tells a big story here. That's why I want to talk about it. I'm going to summarize it for you. The first thing I want to do is I want to talk about what we do at WEI as a company, right? We do networking and wireless projects and virtualization and firewall projects and everything under the sun, right? But in any project that I'm a part of, right, no matter whether it's networking or wireless or whatever it is, our number one job at WEI is to keep our customers safe and secure, right? At the end of the day, every project to me is a security discussion, right? Like it or not, security creeps into it one way or the other. So if I look at this graphic, to me, it's a very sobering thought, and it tells the tale of what's out there. The top 8 cyber attacks of 2024. If I look at the top 5, the phishing attacks, ransomware, denial of service, man-in-the-middle attacks, SQL injections, those are all the usual suspects, right? Those are all the usual things that have been happening for the last 10, 15 years, right? Nothing really new there. It's all stuff that we want to defend against. That's something that a SASE service can defend against. The sobering part of it is that zero-day exploits, those used to be something that wasn't even in the top 20. Now it's in the top 8 cyber attacks of 2024. If I look at this one bullet right here, zero-day malware explosion, right? In 2019, I've been looking at this for years, and I've been sort of like looking at the data for the last 10 years or so. 2019, in this, like the industry players out there categorized and prevented 2 billion pieces of zero-day malware. Zero-day malware means that it's never been seen before. They categorized it. They were able to mitigate it, block it using their product, right? That's what zero-day malware means, right? Previously unknown, now it gets turned to known, right? They categorized 2 billion pieces of malware daily. That includes malware campaigns. They were able to block them, right? Just 3 years later, it ballooned up to 224 billion pieces of malware daily, right? What other technologies does anyone know of that came up during that time? Things like AI and things like that. So these hackers and all these people, they're outpacing security controls every day. They're leveraging automation. They're evading and overwhelming defenses. They have sophisticated tools, AI-based tools. They have Cobalt Strike. They're encrypting command and control communications to steal your data, right? To basically leech off of you. Like you've done all the hard work to build your business. Now someone else wants to steal your intellectual property and the things that make your company tick when your applications are everywhere, your users are everywhere, and your branches are everywhere, and your company data is everywhere, and now the attack surface is expanding like never before. You have to take back control of that. Don't be a sitting duck, right? It's easy for anyone to leverage automated customizable tools that are free or cheap downloadable tools to encrypt communications, evade defenses, and grab your data out of your network, bypassing traditional technologies. This is definitely a bad confluence of circumstances. It's a perfect storm. Attacks today are automated with AI and things like that. They're innovative. They spread quickly. They're built to evade signature-based defenses. They're difficult to outpace, and the attack surface is growing with users, applications, branches, and perimeters everywhere, right? Then you couple that with some of the traditional tools out there, like on-prem security solutions like firewalls. They use signature-based detection and prevention. Signature-based detection and prevention really is reactive, right? It's 1990s technology. The threats have to be active and known before signatures are produced based on fixed data pattern matches. It's kind of like a wanted poster in the Old West, right? Or at a post office, right? It's, yeah, hey, we knew about that. We prevented it within hours, but it happened within seconds. There's a disconnect there. You've already been attacked, right? So it's detection after the fact and then remediation. It's reactive. It's relying on manual updates, which are required to ensure up-to-date protection. And it can take hours for these companies to develop them and deliver them, AKA they can't keep up with the attackers, right? So the goal that you want to get to is real-time, up to the second threat prevention to stop known and unknown, net new, evasive, zero-day threats and malware in line. Can't stress that enough, right? You need a product that outpaces attacks and attack campaigns, continuous threat inspection in line, real-time analysis of unknown threats, examining large data sets and millions of data points using AI and machine learning and deep learning, finding commonalities and patterns, exposing anomalies, finding net new unknown threats, continuously self-correcting and learning with data curated over time by your SASE vendor to stop exploits, vulnerabilities, and malware and evasions, antivirus at the perimeter with infected file detection and real-time stream-based scanning, anti-spyware and DNS security at the perimeter to block command and control callbacks and stealing your data and blocking that real-time packet flow. The speed of threat mitigation is key. Why is this important, right? Take back control of your data and your environment. Do not be a sitting duck. WEI can help you not be a sitting duck, right? Prevention of unknown and known malware should be natively integrated within a SASE service and easily implemented and deployed across all users and locations with no change to infrastructure, while new threat prevention techniques are easily implemented. The networking of traffic from source to destination, security policies, application identification, understanding the context of which users and which user groups can access which applications, then threat prevention techniques, as well as SSL and TLS decryption, are all performed in line, in real time, with your SASE service, significantly reducing the amount of processing overhead in one global scalable security as a service with a single GUI and a single point of management. During the purchase decision process, if you go through that, looking for a SASE service, you need to do a proof of concept, prove out that a SASE solution of your choice has the ability to perform deep packet inspection and prevent known and unknown malware. WEI can definitely help you do that. I would gladly help you do that personally. All right, enough for, I'll stop ranting at this point. I'm going to start wrapping everything up, I promise. I'm kind of under time. The next thing is just ask yourself some questions, right? In wrapping this up. Is there poor user experience in your environment for mobile users and branches? Is your data perimeter, users, branches, data centers, applications, is it spinning out of control? Do you even have visibility into that? Do you have disjointed security enforcement? Do you have expanding costs? Do you have one GUI to manage everything? The call to action really is, if security and all these things keep you up at night, stop now and transform your network, transform your security. You can roll SASE out in phases, right? You could roll out groups of mobile users and then eventually gravitate toward rolling out all mobile users connecting to a SASE service. Roll out branches and then eventually move those over to SD-WAN, implement SaaS security. You can roll all of these out and manageable project phases instead of rolling it out all with one, like Big Bang Theory type of implementation. Roll it out in manageable project phases, do a proof of concept. WEI can help you. As Todd mentioned at the beginning of the presentation, the next step for everybody here would be to have a SASE workshop, contact your sales rep, set that up. We can talk through your environment with you, what your challenges are, kind of take an empathetic approach, put ourselves in your shoes and do what's right for you, right? With what you're comfortable with. Um, that's all I have for today. And we can, Todd, I'll turn it back over to you.
Yeah, absolutely. Nice work, Terry. I mean, that I've
It's a
seen you have
lot.
a conversation a number of times, and it's a lot of information to put out there and for the customers and people attending to digest. So thank you.
Yeah.
As Terry mentioned, we're here to help you guys. We could do virtual conversations to continue the discussion. As I mentioned, we'd love to have you up to our facility. We've got a lot of this stuff running in our labs. We're consumers of this technology. So, and as some folks asked on the chat, you know, there we yes, we do have matrices and comparisons that we've done real world for our customers. So happy to share that with you guys. You know, often it does require some discussion about what your current technology estate looks like and where you want to go. Um, if you guys look at, you know, where the spend is happening today, total addressable market, this is the largest, according to customers, this is the largest single expenditure customers have these days is moving to an evolved network and security delivery model like this.